Okay, so here we are. Number 7, practice M5, number 7. Ron and Kathy are ticket sellers at their class play. Ron handling student tickets to sell for $2 each, and Kathy $5.50 each. Total income 30 tickets, $105.50. How many did Ron sell? All right, so we have 3 kinds of word problems. Is there 3 or 4? I think there's 3, maybe 4. Anyway, this is a money one. And then number 8, you can kind of see number 8 is going to be another money one. And then number 9 is going to be mixture. And then we also have travel, like cars and stuff. Trains and cars and planes and stuff. Right. So those are the 3 kinds. Do we also have direct and inverse? No, that was the last exam, wasn't it? That was the last exam, yeah. So in this exam, we have 3 kinds. We have the money, the mixture, and the travel. So what do we do? These first 7 and 8 here are money ones. What do we do on a money word problem? Do you remember? We have 2 equations. The first one is no money at all, and the second one is all about money. Remember that, how that works? So the first one, no money. Okay, so first one's no money. So you tell me which of the numbers, look at the numbers up here. Here's $2, here's $5.50, here's $30, here's $105.50. Which of those numbers is not a money number? 30. Only the 30. So the first equation is going to be equal to 30 because it's the no money equation. That makes sense? It's not going to have the other numbers. It's just going to have the 30. What's it going to be? The 2 kinds of tickets. What are they? Student and adult. So student and adult. Yeah, right. That might be better, huh? Ron and Kathy, because they're asking Ron in the end. Let's just do R and K, Ron and Kathy. Yeah, that'd probably be easier. Ron and Kathy. How many tickets they sold? 30. Is that good for the first one? That's just however many tickets Ron sold plus however many Kathy sold is 30 total tickets. Nothing to do with money there. Just treating them like objects. We don't care what they're worth in equation 1. Equation 2 now, we care about what they're worth. Ron's tickets are $2 each, so 2R. Kathy's tickets are $5.50 each, $550K, and the total income $105.50. One mistake people make because we do the mixture is they'll multiply these together, go 105.50 times 30. Easy mistake to make, but if you think about it for a second, that's not right? They're not saying the person got $105.50 30 times. Right? They're just saying total 105.50. So watch out. For the mixture ones, we do multiply those last 2 numbers on the second equation. That's why it's easy to get them confused. Everybody see that difference? So on the mixture, yes, we will multiply. But on the money one, it's just, that's the total money. They're not saying 30 times that. That good? So the first equation, no money. Second equation, all the money, right? Money, 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 and all 3. All right. So now, we got our 2 equations. How do we solve them? Yeah, whichever. I don't know which way you guys like better. You like elimination or? Yeah, I just want to do whatever the majority likes because either way is good. Am I confusing you? Do most people like substitute? Do you know what I'm talking about? So in other words, there's the way where you get R alone in the first equation, plug into the second. Is that what you like? Or the one where you multiply the top by -2. You guys are like a mixed group. I don't like either one of them. All right, well, I don't know what to do. I'll just move the K over. That's what I was doing before was the plug-in method. So let's move the K over like that, and so that'll be R equals 30 minus K. Is that good so far? Move that over. R is 30 minus K. And then take that and plug it in right here for R in the second equation. That's called the substitution method to plug in. The other way is you could have just multiplied the top equation by -2. Just -2R, -2K, -2 times 30, and then add them, and the -2R and the 2R will be 10. Either way is fine. So I'm going to do the plug-in thing. So here we go. I'm going to do the plug-in thing. So I've got 2 times R. What is R? 30 minus K. So there's my R. Plus 550K is 105.50. Good so far? And so distribute. So that would be 60 minus 2k plus 550k is 105.50. Everybody tracking so far? So what? Minus 2k plus 550k. What's that? Plus 350k. Now, I'm trying to subtract the 60 from both sides. So 350k is, what's that, 4550. Like that. Last step to get the k alone. Divide by 350. K is, I don't know, is that 15? 13, thank you. K is 13. Kathy sold 13 tickets, that means. But they're asking me, watch out, see how they're trying to sucker us in 13, but that's wrong, huh? Be careful. Why is that wrong? Because it's Kathy, and they're asking for Ron. So watch out. They're always trying to fool you with that. At the end of the problem, these publish or test bank questions, they're always trying to do that. Watch out. Make sure you answer the real question. Well, the real question is how many did Ron sell? So how do I find the Ron number? 30 total, huh? You can always just subtract at the end. 30 total tickets, it says. So 30 minus 13, what's that? 17? 17 for Ron. So it is C. Ron sold 17. Does that make sense? At the end, you can just subtract because you know the total number of tickets was 30. So 13 for Kathy, subtract from 30, 17 for Ron. Questions on that one? Does that feel doable on today's exam? Money problem? All right. So Ann and Nancy, metal alloy, 24.9% copper to make jewelry. How many ounces of 20% alloy must be mixed with 27% to form 100 ounces of the desired alloy? Okay. So how do we do mixture problems? The boxes, the 3 boxes or beakers or whatever. 3 beakers like that. Good. The top goes the amount. The bottom goes the percent. That's right. Okay, top goes the amount, bottom goes the percent. Okay. Now, there's something tricky about the way you put the percentages in. If I just go like this, if I just go, don't write this down, this is wrong. 24.9%, 20%, and 27%, I'm in trouble. That's not right. Why not? Yeah, think about when you're mixing things, right? This is chemistry class here, right? There's a little mixture problem. I think I told you my middle daughter likes chemistry. I'm not sure exactly why. I'm never thrilled. I took a little chemistry and it seemed very painful to me. But anyway, so if we're mixing things, so something weaker and something stronger, when you mix them, the final thing comes out in the middle, doesn't it? Right? Like the stronger and the weaker, the final thing is between. Right? That's what it means to mix things. So that means the final one has to be the between strength. So this isn't right. 27 is higher than, that's the highest one. So which one of these 3 numbers? Which one of you? 20, 24, 27. Which one of those is mid-level? 24 is between 20 and 27. That's the mid-level. That's the one that has to be on the end, you see? I don't even need to read the words. I know the mid-level has to be the final product, right? These 2 add up to equal this final mix product, what they're making. Huh. So that makes sense. You mix something stronger and weaker, the first 2, to get a final thing that's mid-level strength, right? So they're trying to trick me in the order in which they put those in the words there and everything. But if I just know that fact, the mid-level, the 24.9, that's got to go right there because that's mid-level. That's between the other 2. And then the other 2, it really doesn't matter which one you have where. As long as you got the final one right. Does that make sense? When you're mixing things, the mid-level has to be at the end. Is that good? All right. So let's keep going from there. Now it says 100 ounces. So where's the 100 go? That's at the end. Of the desired alloy. And that's, they're making this. This is the desired alloy. 100 ounces. So what goes in the other two blanks? X and Y. X and Y. All right, and now, so there's my picture, but how do I get my equations out? So the first, two letters, we need two equations. How do you get your first equation? Yeah, just the tops. So just right across the tops, huh? X plus Y is 100. Top, top, top. How do you get your second equation? Yeah, multiply top and bottom, huh? So top with bottom, 20x. And I don't even need to change the decimal. I don't need to make it 0.20. Remember how we learned that? Because you could just get rid of them all. Here, I'll show you what I mean. 27y, top times bottom, top times bottom, top times bottom. 24.9 times 100. Yeah, if I put the decimals in all three, because really that should be 0.20, 0.27, point right here, then I could just multiply, because it's an equal sign, got a left and right, I could just multiply the left and the right all by 100, right? You can do the same thing to both sides of an equation anytime you want. And the 100, the two zeros would move it back, back, back. So I might as well skip the whole thing. Does that make sense? If you have decimals on both sides of an equal sign, if all the terms on both sides of an equal sign have decimals, well then you can just skip it, because you could get rid of them by multiplying both sides by 100. Does that make sense? So we just go right to here, and let's just figure this out with our calculator, right? 2490 on that. I just multiplied those two on the calculator there. Just moved the decimal two places is what it did. All right, there's my two equations. How we solve them? Same way we did a minute ago with the money ones, huh? Just move this over, get x on. X is 100 minus y.
Multiply the top, do the elimination thing.
You could multiply through by negative 20.
Negative 20. Okay.
And that would do it too. Yeah, if you like the elimination method, you can multiply negative 20, negative 20, negative 20 in the top. And then when you add the x's will drop out.
Yes.
That'll work too. That's the elimination method. I'm doing the substitution method, but either is fine. Plug that in for x right there. So I get x alone in the top, plug it into the bottom. And then what do we have? We have 20 times x. What is x? This, 100 minus y. Plus 27y is 2490. We good to there? And then boom, boom. 20 times 100, what's that? 2,000 minus 20y plus 27y is 2490. What's this? Minus 20y plus 27y is 7y. Like that. So subtract 2,000 from both sides. 7y is 490. Bring it up here. 7y is 490. Last step to finish getting y alone divided by 7. Y is, what's that, 70? Y is, now do they want y? Or do they want x? That's kind of tricky. How do you know what they... Yeah, look for the how, the who, what, when, where, how, who, what, when, where, why, how, those kind of question words, huh? How many ounces of 20%? That's actually their only question. The rest is all information, but not question. The only actual question is how many ounces of the 20%? The 20% is X. So they want X.
So you do 170.
Yep, right, yeah, the total's 100, totally. So take 100 minus 70, 30. So X is 30, 30 is what they want. So see how they have that 70 answer there? They're always baiting that hook and throwing it in the waters of our test. Watch out for those publishers.
No.
Is that good there, 30? So want to write that one on your 3x5 card, mixture problem. If you need a whole one laid out, there it is. No questions? We all good? All right, so Marty and the airport and the private plane. So what kind of problem is this? Travel dirt equation, right? Couple of dirt problems looks like. So distance equals rate times time. Right, later is less time, huh? When you leave later, you got less time. Subtract, good. All right, so we got Marty and his plane, and then we've got a jet. So there's a plane and there's a jet. There's the two rows. And let's see what it says here. Plane, 186 miles an hour. Is that a distance, a rate, or a time? That's a rate for the plane. That's the plane rate. 2 hours later, yeah, that's talking about the jet. That's the jet time, x minus 2, because if you leave later, you have less time to fly, right? X minus 2, which means the other one's x. Remember, one of the other boxes is always plain x. We good with that? Getting the hang of that? 434, much faster. That's the speed for the jet. All right, good how I filled that in? Question?
Can I do
X plus 2 here? Totally. And then regular x here? That'll work great too. Either way, yeah, because basically if the jet leaves later, then the plane leaves earlier, so it's plus 2. It'll work either way. Yeah. So now, how do we get the front boxes? How do we get this box and this box? Do I need to read the words, looking around for it?
No, because you know.
We know from the boxes, huh? Yeah, because remember with the equation, it's not just the letters are related, they're connected. The D equals R times T, huh? So sometimes that's why I see people just write DRT, but they don't write the equals or the times. Write that because that helps you remind you of the relationship there, how they're connected. So the D box will equal the R box times the T box, huh? So we can come up with those automatically just by multiplying. So 186x and 434 x minus 2. That good? So those are the two D boxes. Now, what do I do with those boxes? So I got all my boxes and everything, but what do I do with them now? What do I do? I have to write an equation. Do I just take the 186x, this box, and set it equal to the 4, kind of getting scribbly there, 434x minus 2 box? Are they just equal? Mm-hmm. Yeah, why? Why are they equal? Why is the distance the same? Does it say same distance? Overtake, catch up, pass up. That always means equal distance, right? When somebody catches up with somebody, at that moment they've gone the same distance, huh? Yeah, that means equal. So catching up always means, right? We had the problem where the little toddler ran off and the mom caught up, or, it's all the catch-up ones. What's that? Equal distance, right? Because when the moment of catching up, they haven't ran for the same time necessarily, but they've covered the same distance when you catch up. Yeah, exactly. So yes, now we just solve this.
So when you draw the little lines, if the lines are equal, like your little demonstration lines.
Yeah, distance lines.
You know that you can do those two just like against each other.
Equal to each other. Yeah. That's right.
Wait, what did you say, Daniel?
She's talking about drawing it out. I'll draw it out in a second. But what the main point I said is any problem they give you where one person or thing catches up with the other, to catch up means equal distance, because that's what it means when you catch up. At that moment, you've covered the same distance. Like if one runner takes off first, another runner catches up. Like Danielle runs in races. She knows if you catch up with something, you don't catch up. I was talking to somebody at a thing last night, and he ran in the Boston Marathon a couple weeks ago.
Wow.
He's going to run in the San Diego Marathon here in a few weeks, and but he disqualified himself in the middle of the Boston. I guess the weather was super cold. I don't know.
Raining.
Yeah, they said it was super cold, and like a bunch of people dropped out, got all shivery and dropped out. Anyway, yeah, no, but I'm impressed just that he was in the crazy thing. All right, so So catching up always means equal distance. Catching up always means equal distance. Okay. So there's our equation. So what do we do to solve?
You want to get x alone.
Yeah, get x alone. So just subtract one of them, huh? Like that. Get rid of one of those x. When you have x's on both sides, you just subtract one.
48.
What is that?
Minus 248.
Thank you. 248 minus 868. Last step. Minus 248. Is it, what is it?
3.5.
3.5. Now, this is real. Don't quickly go grab that. I mean, it might be right, but let's be super careful. Remember, they're trying to trick us on the end of these. Wouldn't it be a bummer? Do all that good work to get tricked at the end? How do you avoid getting tricked? Read the question. Be really clear. Because remember, this is the key. It'll unlock any of those doors. Which door do they want? When will the jet overtake? When? That's one of those question words. Who, what, when, where, why, how, right? When, jet. When is what? Distance, rate, or time? When? Time. That's time for jet. It's right here. So you got to plug the 3.5 in right there. So it's 3.5 minus 2? 1.5. It's not there? Oh, that's really a devious problem, isn't it? So it's 1.5 is the actual answer, which is none of the above after all that. All right, does that make sense? No one's going to get tricked today, right, on the ending of these words. If you do all that good work, I want you to get the question. So just always be careful. Make sure you're clear on what they're asking for. Now, I don't know, like you were saying, you switched these guys, and that's okay if you did that. You would automatically get the x 1.5 that way. Because your x would be this box, and it 1.5 straight out. And that's fine that way, too. All right. Are we good? Want to try one more car one? All right, so it's another dirt one. Looks like we're going to have 2 dirt ones on the test today, a couple money ones, and a mixture. So here we go. So distance equals rate times time. Okay. 2 cars, so we just have car 1, car 2, I guess. All right, let's put the information. One's going 50 miles an hour. Is that distance, rate, or time? That's a rate. 50. The other's 70 miles an hour. That's the other rate. And how many hours will they? 60 miles apart. 60 miles. Miles, is that a distance, rate, or time?
That's on your other side of your equal.
It's a distance, but I can't put it there and I can't put it there. Because it's not the distance for car 1 or car 2, it's how far apart they are, which is different than how far they've gone. See the problem? I can't put it in, it doesn't go in those boxes. So what do we do with the 60? Let's hold off on the 60. It's going to be part of what we equal in our equation in a minute. See how I know that? Why? Because they never said, hey, car 1 went 60 miles. If they did, I would have put 60 in here. Or both cars went 60 miles, then I would put 60 in both. They said they're 60 apart. Well, that's different than how far they went. So I can't, these boxes are how far they went, or how fast they went, or how long they went, not how far apart they are. So I can't put that 60 in the boxes. Got to save the 60. Okay, but I need these right 2 boxes so that I can do the multiply, and do the other 2. What do you think goes in those right 2 boxes?
Time. It's the same time.
Good job. Everybody see that? It's a really important word, right?
Because they left
Whoops.
at the same time.
Exactly. Same time, huh? So the 2 cars, however long they drove for, it's the same because they left at the same time. Get the picture? What's happening is they left at the same time, same direction, but one's going faster. So the gap between them keeps growing and growing and growing, but they're driving for the same amount of time. They're just getting further apart because one's going faster. So anyway, this is both X, huh? Everybody good with that? Because it's the same time. Now, I know we had that one bus. Didn't we have a bus? Somebody ran and bus, and that was X
Oh,
of
they
Y.
bussed and they
I'm not
walked.
gonna do that exam. Probably. I don't think, no. That was a hard question. That's why we use X and Y, because they're different. That's why I had to use different letters, because because he ran for a while, he buzzed for a while, I didn't know how much each one was X and Y. But these ones are same time, so I use the same letter. Right? That's what you can expect on the test. Okay, so we have the 4 boxes on the right. How do I get the boxes on the left? Times, right? D is R times T, so 50 times X, 70 times X. Now I'm going to pop those out, and I got to do something with those and the 60. I got to write my equation using these guys and the 60. Do we add them or subtract them? How do you know? Yeah. Let me draw a little diagram of what I just acted out for you. One car's going to the right faster, the other's going to the right, but not as fast. So the gap between them, here's the gap between them, right? The gap between them is growing. What's the distance the one on the top goes? The faster one's 70x, right? He's going faster. The slower one is 50x, that's the distance he covers. So you see how and how big's the gap? 60. This gap is 60. So do you see 70, the big one, take away the small one is the difference. So in other words, 70x minus 50x is 60.
Did you show me that yesterday? But looking at that, I see 50x plus 60 equals 70x. I mean, that's okay to do it that way too.
It is.
Yeah, because you're still going to have to subtract.
Right. Yeah, let me so what you just said, I like what you said. You're saying, look, this, you're saying 70x is 50x plus 60. It is. That's true also. And see, if you jump this over, it'd become the other equation, wouldn't it? Negative 50? See how the two equations are the same? That's the beautiful thing I like about math. As long as your thoughts are clear, your thought is totally right. The particulars don't matter. As long as the logic is right, the equations will always be true. Yeah, and you're right. That's another good logical thought. Good. Does that make sense? So either way will work fine on that.
So do 70x minus 50x equals 60?
Right. Does everybody see why that's the case up there? Right? Because the longer line, say this, like what if I had a long line and said, hey, this is 10 miles and this is 8 miles and the gap between them from there to there is 2 miles. The big one minus the small one is the difference, huh?
Yes.
Get the idea what I'm doing? Saying the big line minus the small line equals the difference between them. Like that. So the big one, the 70x, minus the small one, is the gap between them on that. Now, we did have in the homework, well, let me finish this up first, and then I'll help you know that it could be another way, and I don't remember which way it is on the test, but it could go another way. All right, so this is easy to finish up. This is just 20x is 60. Divide by 20. X is 3. Now careful. What do they want? They could ask us for any of those boxes. That's the key. It'll unlock any door, but let's make sure we unlock the right door. Where's the who, what, when, where, why, how question? How many hours? How many hours? Is that a distance, a rate, or a time? Time. Hours is time. Time. They're both the same. They're both just X. It's just 3. It is just 3. And it is there. So that one, no trick on that one.
And what did you say about the test? There was something on the test.
I'll get there, yeah. But watch out. They could have said, how far did the slower car go? So that would have been, you would have taken your 3 and you would have plugged in there. 50 times 3, 150 miles. Or how far did the faster car go? Plug your 3 in there. 70 times 3, 210 miles. Right? They could have asked that. Right? So watch the who, what, when, where, why, how question. How many hours? Okay, they just wanted time. They just want X. X is 3. Done. Yeah, now, the other way they can do this is they could say, what if the cars are headed at each other? So we had some of those in the homework, where we would have one car starts here, one car starts there. They head at each other until they collide. No, well, they meet, two towns, and they meet some town in between. This one, maybe the same thing, 70 miles an hour, 70x, 50x, the two towns are, 180 miles apart or whatever. How long till they meet or whatever. What would I do in that case? See how 70x plus 50x would equal 180? See how the two pieces would add to equal the total? I wouldn't subtract. In that case, I would add. If they're headed at each other, then however far this one went, he covered part of the gap. he covered the rest of the distance. Together they made the whole 180 distance, didn't they? Together they add up to equal the whole 180. Does everybody see that?
No.
So there's two different kind of things going on.
So then if they're going at each other, you would add them.
Right. Does everybody see that? So let me give you the rule, and then let me give you the logic. So, same direction. Here's my little memory device. You can write it on my card if you want. If they're headed in the, I'm running out of place to write it here. Same direction, subtract. SS. Opposite directions, add. There's.
I thought you said.
So let's look back.
Oh.
So there's a difference between headed at each other. These guys are headed. This guy's going to the right. This guy's going to the left. That's opposite directions, isn't it? Even though they're headed at each
So
other.
it would be 70x plus 50x
Yeah.
equals 180.
Opposite direction,
Add.
add.
Yeah, so see how the problem they gave us, see how these two cars were going in the same direction? Both going to the right, so I subtracted SS. Same direction, subtract. But if they're headed in opposite, see, headed at each other means opposite directions, doesn't it?
Okay.
Don't let that throw you off. You can say, well, they're going to the same point. Okay, yeah, but they're headed in opposite directions to do that. If they're headed at each other. One's going that
So
way,
you would
the other's
do
going that way.
Plus 50x.
You would add.
Okay, all right.
What would
Everybody
you
see
do
that?
if it asked you, would it ask you, like, where they met, like, how far in their trip they met, or would it only one time?
They might ask you that. That would just be one of the boxes which you can unlock easy once you had your address. How far did car one go? Or how far did car two go? Or how long did car one go? Right? They can ask you anything. You get it easy once you solve. You know, that just like asking for any of these boxes. That part won't be hard. But the setup, everybody get the setup. So same direction, subtract, SS, same direction, right? Because there's the difference. The gap is the difference in how far they've gone. Subtraction. But if they're headed at each other, this one covers part of the distance, that one covers part of the distance. Until they meet, together they add up to cover the whole distance, don't they? They add up. Everybody see that? So there's the difference on those two. So I don't know which one's on the exam. We had both in the homework. So, what's the rule? Same direction, subtract. Want to put that in your 3x5 right now? Same direction. So on a dirt question, if you have two cars headed same direction, subtract, opposite direction, add on that. Catch up is equal. So we've had three varieties. Remember the jet problem we just did? So I don't want to confuse you. On the jet problem we just did, the jet caught up with the plane. And so we equal distances. We didn't add the distances. We didn't subtract the distances. We set them equal. Are you tracking with me? So there's three varieties of travel problems they can give us. They can have the toddler runs off, and the mom catches up, or the plane takes off, or the jet catches up. So if you catch up, that's equal. The minute you catch up, you've covered the same distance. Equal distance. That's different than, the two cars leave, and there's no catching up. The one just keeps getting further and further ahead. So then you go, oh, that's not a catch-up. Okay, then it's either an add or subtract. Which one is it? Same direction, subtract. Or the two cars are headed at each other, so they meet. That's not really catching up. They're headed opposite direction. Opposite, add. See the three different varieties? On that? All right. Also, let me give you one more hint. Back here in the jet problem, see how there was, if you were wondering, if you were looking at this jet problem, and you were thinking, this is what I'm doing for you right now is really what you want to do for yourself. Your next math or science class, this is how you learn math. Look what I'm doing. I'm looking over the problems and comparing and contrasting small differences, That's really important for you to do for yourself. That's exactly how you get ready for a math or science test. You want it, it's all about a lot of the battle is identification. Look at this jet problem. Do you see how there's no other number? If other number that's outside the box. What I mean is, every number in this problem I put somewhere in the box. There was no extra number they would ever add up to equal or subtract to equal. That's how I knew I was just going to set them equal. I was going to take this and just set them equal. There was nothing else they could add up to be. Whereas in this problem, the 60 He was nowhere in the box here. I knew I had to either add or subtract something to be that 60. See how there was an extra number in this 2 cars leave town at the same time problem? If you got an extra number that wasn't in the boxes, then you know you got to add 2 things or subtract 2 things to equal that number, huh? Whereas the jet problem, there was no extra number, so you know you're going to set them equal. There's nothing to add up to equal. There's nothing to add or subtract to total. There's no other number, so you're going to set them equal by default. So that's just the rule of thumb. If there's no other number, set them equal. You catching me?
No.
Right? When you do this boxing, when you're reading the numbers and you do the boxing, by the time you're done with this box here, you have all the numbers. There's no other number up there that's not already been used. There's no extra numbers. So there's nothing else to do but set them equal. There's no other number to add them up to equal or subtract them to equal. There's no other number. Everybody see that? They're all in the box. So if there's no other number, just set them equal. Whereas in this problem here, there was an extra number. There was the 60 that's not in the box. I had an extra number I had to do something with. That's when you go, oh, I must need to add them or subtract them to equal that 60. Makes sense? Same direction, subtract, opposite add. All right, we better. So square root of 150x squared y. What do? 2 for 1. It's all about 2 for 1, huh? Just break down that 150. 15 times 10, right? Things end with a 0 or times 10, aren't they? 15 times 10. 3 times 5. 2 times 5. So what do we got? 2 5s in. 1 5 out. X squared y is xxy. 2 x's in. 1 x out. What's left over inside? They're gone. And these guys are gone. 3 times 2, 6, and the y. 6y, done. 5x root 6y is A. Good on that? 2 for 1. Next one. Square root of 25. That's 5 times 5. 2 5s in. 1 5 out. Or you just say square root of 25 is 5. You know that. Now, what do you do with these powers on these m's and n's? Cut them in half, right? Cut them in half. Yeah, so now the odd one, I can't cut 17 in half. So what do you do with an odd one? Remember, you make it 16 with 1 remainder. Remember, you always make it even with 1 remaining. That's how we always handle odd. Cut that part in half. That'll be m to the 8th, into the 6th and a half, into the 3rd, and that 1 m remains in. Remember that? So even powers, we just cut them in half because it's a 2 for 1 deal. If you're going to Target and they have 6 items, you pay for 3. Right? So the odd, 17 items, I just make it even with 1 remaining, cut the even in half. All right. So square root of 49 over the square root of 10. 49 is 7, 7. 10 is 2, 5. Good, just break them down. 2 7s in. Now, those 2 7s are in on the top. So when they come out, they'll also be on the top, won't they? It's 7. And the 2 and 5, they have to stay 10. They can't come out. I'll just leave them 10. I don't know, maybe I'm confusing you by doing it this way. How about, I mean, it's true what I'm doing, but how about I just go, look, root of 49, 7. But I can't root the 10, so it stays there. How about that? Is that a little cleaner?
Yeah.
And now I got to multiply top and bottom by root 10. Everybody seeing that? See how the root vanishes on the top because you can root 49 and it's just 7, but you can't root 10, so it stays there, and you can't let it stay there. No roots in the bottom. So multiply top and bottom by root 10, get 7 root 10. What's root 10? Root 10 in the bottom.
10.
Plain 10, because that's 2 10s in, 1 10 out, huh? 7 root 10 over 10. A lot of A's. A answer. Good there? How about this next one? Root 81 over 40. What's the root? Can we root the top?
9.
Yeah, that's just 9, and the root vanishes. Remember, when you do the root successfully, it's gone. It does its job and goes home. It's out of there, right? We've rooted the 81 to be 9. Now the 40, I can't root that. But I can break it down. Right? So let's... Now, you might think, well, can't we just multiply top and bottom by root 40 right now? You could. Is that what you did? I mean, it's okay. Might be a little easier to break. It's not a big deal. One way or the other. I'll do whatever Whatever you think. I'll just go ahead and do that. It's not a big deal. Multiply top and bottom by root 40 right now. I can do that. Yeah. Yeah. You want me to do that first? Yeah, that's what I would do too. I agree with you, Jemima. It's a little easier that way. 4 times 10, 2, 2, 2, 5, and then we have 2 2's in, huh? So we can send a 2 out. 2 comes out. What's left inside? 2 times 5, 10. Yeah, that's going to make it a little easier. Do that first. It's a little easier. Now, we can't stop there. Got a root on the bottom. So multiply top and bottom by root 10. 9 root 10 on the bottom. Yeah, root 10, the 2's there. Root 10 is plain 10. And so that's 9 root 10 over 20. There it is. Everybody see what happened there? So from the top again, I rooted the 81 to be 9. So the root's gone from the top. Because when you root something, the root's gone. The bottom, the 40, I broke it down to be 2 root 10. Multiply top bottom by the root. 9 root 10. No, root 10, 2 10's in. Right? 2 10's in. Made 1 10 out. All right. Okay, so the 8 is 2 times 4, 2 times 2. So 2 2's in. 1 2 comes out, and it's going to multiply that negative 5 that's already out there. So watch out. When you've got stuff already in front of the root, it's easy to forget about it, but you got to remember that negative 5 is already out there. So these 2 2's will send a 2 out. That'd be negative 10 root 2 when that 2 comes out. Minus 4. Now what about the root of 200? 2 times 100. 100 is 10 times 10. I don't need to go any further. Don't bother to go 2525. As soon as you see 2 of anything, you don't have to go further. Does that make sense? Am I going too fast? Everybody see what I'm doing there? Everybody see that? So 2 10's in is going to send 1 10 out. It's going to hit that 4, that negative 4 that's already out there, to be negative 40 root 2. Everybody see what happened there? So I broke that 200 down. It'd be 2 times 100, and the 100 is 10 10. So 2 10's in. Shift 1 10 out. Yeah. And hit that 4 that's already out there. This would be 40. And then all that was left in was this leftover 2 here. Is all that's left inside. Daniel?
If you had like negative 10 root 5 and negative 40 root 6, that would be your answer, right?
Yeah, because those would be unlike terms, can't go any further.
That's it.
Yeah, Daniel's right on the money. If I got this kind of an answer here, different roots, unlike. Remember, roots are about, it's like different letters. That'd be like having minus 10x minus 40y. We would just leave it. They're unlike, can't add them, done. Right? Different roots are like, they're unlike. So it's all about like roots or unlike roots. So now at this point, these are like roots, aren't they? So we can actually combine them further, can't we? So minus 10 roots of 2 minus 40 roots of 2 is minus 50 roots of 2. It's like minus 10x. It's like minus 10x and minus 40x. That's basically, these are like x's, aren't they? The roots are like x's. Same roots are same letters. Different roots are different letters. Good there? Number 19. Let's try it. So 19 is a FOIL. So 5 plus root 7. 5 minus root 7. Here we go. 5 is going to go boom, boom to both. So we good on that? Remember, the first one goes to both the 2 and the other parentheses. So first to both. That'd be 25 minus 5 root 7. It stays outside. Remember, outsiders stay outside, insiders stay inside. So he's done. Everybody okay with him? He went first. And then this root 7 is going to go boom and boom. Plus 5 root 7 minus, what's, here I'll just write root 7. What is root 7?
7.
Plain 7, because 2 7's in, 1 7 out. And these guys cancel. So it's 25 minus 7. See how these guys canceled here? So minus 5 root 7 and plus 5 root 7 canceled. So it's 25 minus 7. What's that, 18?
Yes, 18.
So there it is.
I can do this all day. I'm all over on that.
Questions on that one? Not good? All right, so what do we do with a root on the bottom like that?
We multiply it and we change it so that it looks.
Good, yeah. When you got the root and the plus or minus, that's when you got to do the conjugate. I don't care if you know the name, but they're glued, so you got to use the whole thing, opposite sign in the middle. Remember that? So it's 8 plus root 3 over 8 plus root 3. Is that good there? Right, got to do that top. So when you have a root and plus or minus, use opposite sign in the middle. Opposite sign in the middle.
That step, then you do a negative.
What's that?
If you forget that step and you do negative, does it make the problem harder?
Yeah, it'll
Or is it
mess.
completely,
It'll be crazy.
or does it completely like give the wrong answer?
Yeah, it's completely wrong. It won't get rid of the root from the bottom, which is what we're trying to do, right? We're trying to get rid of the root from the bottom. Yeah, this is the only way to get rid of the root from the bottom. So, all right, here we go. You'll see why. So the 2 goes boom and boom on the top. Now remember, outsiders with outsiders, insiders with insiders, no crossing the line. So 2 times 8 is 16, plus, and then 2 times root 3, the 2 stays outside, the 3 stays inside, right? On the bottom, we're going to do the same kind of thing. So here we go. The 8 to 8, 64. 8 to root 3, the 8 just stays out and the root 3 stays in. He's done. So remember, you take the first to both, and then second to both. That's how we always FOIL, right? First to both, when his turn's over, then second to both. Right? So this 8 had his turn. It's like taking a ride. That first one went to both. And now the negative root 3 is going to go to both. Right? This negative root 3 is going to go boom and boom. So negative 8 root 3
So it's kind of like a double foil.
and negative root 3 root 3.
Is that the same thing, Mr. Harris?
You mean top and bottom FOIL?
Yeah.
The top is technically just a distribution because it isn't 2 So it's a distribution on the top, FOIL on the bottom.
Okay.
Yeah. Is that good? And then these guys cancel, don't they? Do you see why the 1 plus, to Danielle, what we're talking about? You said if you use the minus, because these would both be minus, and they wouldn't drop out, therefore. See how this gets rid of the roots from the bottom? This is why we use the opposite sign, because we're trying to get rid of the roots from the bottom. So if you use the same sign, these would, if these are both negative, I make negative 16 root 3. The root would not go away. So that's why you got to use opposite sign. So they drop out. And what's root 3 right here?
3.
Plain 3. So this is 64 minus 3 on the bottom. It's just 61. And we're done.
But how do
Is that what it is?
how can you put that, like 64? Oh, because root 3 is 3.
Yeah.
Oh, okay, I got you.
Exactly. Two threes in, 1 3 out. Yeah.
Right,
Is that good? Let's try 21. All right, so 21. We got y equals the square root of 3y plus. So what do we do when we got a root? Parenthesis 2 power, parenthesis 2 power, right? Because the opposite of a root is a 2 power. And you got to check it, right? So if I was you, when you get the exam here in just a couple minutes, I would look through it real quick, yellow or blue test, and I'd see this root with an equal sign. We've had other roots, like number 20 has roots, but no equal sign, notice. Just roots, who cares? But roots with an equal sign? I would just write C next to that right away. Check. To remind myself, after I'm done solving that one, I got to check the answer. Root with an equal sign. There's only going to be like 2 or 3 of them. You got to check the answer on that.
Root with equal sign is no solution?
No, it's got to be checked. You're making up new rules there. No. Hey, root with equal sign, just put a C next to it. It's got to be checked. It's like number 22, I think, right? It'll be the same thing. We'll get to it in a second. It's got to be checked. So when I'm done, I got to check it. All right, so let's square both sides. Y squared. The root cancels the square there. The root cancels the square. They're opposites. That's why we did it, huh? 3y plus 10. Good to there. So remember how these always work. On one side, it just pulls the shell off the snail. Right? I did not write 2. I did not write 3y minus 10 twice, did I? Why not? There's a 2 here. Why didn't I write 2 of them like I did on the other side?
Peel the snail the shell out.
Because the root canceled out the 2. So there's not 2 of them anymore. The root and the 2 eliminated each other like a poison and antidote. It's just 3y plus 10.
And then that y2 get a 0.
And now what do we do when we see y2?
Get a 0.
Get a 0. Everybody
Factor.
crystal clear? We did a bunch of those yesterday, huh? Or 2 days ago.
Y equals,
Jump it over.
equals 3y.
Minus 3y minus 10 is 0. So once you see x squared, I always call that the sea monster, right? Just y squared, x squared. When you see that, you get a 0. Your first step is to jump. You jump everybody to where the x squared is or the y squared is. You jump everybody to their side. The x squared is the leader or the y squared is the leader. Right? The leader says, everybody to me, right? So everybody jumps to the y squared, leaving 0 on the other side. And then this factors. How does that factor? Whatever multiplies to be 10 adds to be 3. What times what is 10? 5 and 2, yeah, to be 0.
No, negative 5 plus 2.
Yeah, sign in the middle. Always goes on the bigger, huh? Minus 5 plus 2 makes negative 3. In the middle. And then remember you set each one equal to 0 separately. Remember they each get their own 0. Go from a single 0 to 2 zeros. Remember you always do that? And then you jump it over. And if you want to skip this step, it's always just going to be opposite sign from the parentheses, isn't it? So I got negative 2. It's a negative. And positive 5. Negative 2. So you look over here and you go, oh, wait a minute. There's a negative 2. Should I grab that one?
No, because 90% is
Yeah, I have not done this. Check. That's why you got both those answers could be bad, both could be good, one could be good, one could be bad. What if you're running out of time? What's usually the case?
the higher number.
Usually the higher one's good, and the lower one's bad. The answer is probably 5, which is not there, so it's none of the above. I don't have time to check. You just need to plug them in.
It works out. Right?
The 5 does, but the negative 2 doesn't. What's that?
If neither of the answers checked, that's no solution.
Right. If they're both bad, it's no solution.
If they're just not there, they work, but they're not there, that's...
Right. It is none of the above, huh? Yeah.
I want to say, when you check, you can use calculator.
Yeah, oh yeah. Just plug in your calculator, huh? You're just making sure the left side and the right side work out. Step on 22. Yeah, parenthesis 2, parenthesis 2. On the left side, you got to write 2 of them.
Yes.
On the right side, now the right side tricks a lot of people.
You do the power of 2 to the 10.
Yeah,
2 to the x plus 1 because they're separate.
Yeah, the 10 gets squared to be 100. See the 10? He's out in the rain with no umbrella. I'm changing the analogy now. The root is like an umbrella, right? Protecting the x plus 1, he doesn't get squared. Why not? He doesn't get rained on because his roof protects him from the 2 power. He cancels out the 2 power. But the 10 is out and exposed to the rain. No roof on him. He becomes 100. Do you see that? A lot of people miss that and they just make this 10. They'll just come in here and I've seen a lot of people over the years, they'll just go, oh yeah, when I do the 2 power, the root cancels it, but they forget the 10 is not protected. So he does get squared, 10 squared, in other words, which is 100, huh? So anybody that doesn't have a roof, then there's 2 of them. They get squared, don't they? That's why the left side, there's 2x plus 10s. That's why the right side, the 10 is squared to be 100, but the x plus 1 is protected. So there's only 1 of him. See that difference? All right. So as long as you make it through that, you're probably good. Distribute this. This is a FOIL, which I'm going to whip out quick. X squared plus 10x plus 10x plus 100. This is 100x plus 100. This is x squared plus 20x, gathering like terms. 100x plus 100. What we see x squared. What do we always do when we see x squared? Leader says, everybody to me, right? You make the opposite side from x squared 0. So x squared is here on the left side. You make the opposite side, the right side, 0. That's what we always do when we see x squared, is we make the opposite side 0. So I'm going to go minus 100x minus 100. That'll make that side a big old 0. That's what we always do when we see x squared or y squared, make the opposite side 0. Whatever you do to one side, no choice, same thing to the other. These are gone. X squared minus 80x is 0. Bring it up here. So we have x squared minus 80x is 0. What do we do now?
You multiply, you separate it, make it
Factor. Take out the x. What now? Each one gets their own 0. X alone gets a 0, and x minus 80 gets 0. Jump that over. 80 and 0, maybe. You got to check them. Remember, I should have put a c here, right? Because that's a square root with an equal sign. So there's only, what, 2 of them on this test. Probably 2 of them on the real test I'm going to hand you in a second here. That have a square root and equals. Probably, maybe near the end. I don't know where they're at. But put a c, check. So you got to check them. I think they both check, don't they?
Yeah.
So 0 and 80. This time they're both good. 23 is Pythagorean. You don't need me to do that, right? A squared plus b squared is c squared, dot, dot, dot. Let's take the test, huh?